Okay, in this lesson, I'm going to pick up where I left off on the previous lesson about what is a function, and I'm going to talk more about the graph of a function. So I'm just going to quickly just kind of go back to that previous lesson. So if you remember in the previous lesson, we had this function here. So this function, which we showed, which had sort of 4 elements in its domain, and they went to 3 elements in its range. And we had sort of a mapping diagram listing the points, table of values, ordered pairs, and the table of values, and the graph were all ways we could represent this function. Now, there's one sort of obvious drawback to all but one of these ways. And the obvious drawback is, what if there's more than 4 points in the domain, right? Listing the 4 points here and then showing, like, with arrows where they go is not that big deal. 4 points we can do. We can list all 4. We could put 4 points in a table of values. We can list 4 ordered pairs. But the question is, what if there's more than 4 points, right? What if A wasn't just 4 values, but it was 100 values, or 1,000,000 values, or an infinite number of values? Well, you couldn't list them all, right? So you wouldn't be able to do a mapping diagram. You wouldn't be able to list them all this way. You couldn't put an infinite number of things in a table of values, or you couldn't write an infinite number of ordered pairs. But with a graph, you could do an infinite number of points. And the way you can do that, let me just show you. We'll just look at an example. So we're going to go back to the graph of a function. So consider the following function. So I'm going to represent this function as a graph. So just as before, my horizontal axis will be my independent variable x, and my vertical axis will be my dependent f at x. And so I'll put a scale on here. 1, 2, 3. Start here, here. So this is my function that I'm drawing right here. So it's a curve. So my function is represented by a graph, but this graph is a curve. And one thing you might notice is that this curve, or a line, or any curve or line, is made up of an infinite number of points. So I'm just going to sort of answer some questions about this graph. So what is say f at 2. So can we tell the rule or the function for a couple values? So f at 0 means if x is 0, the independent variable, so remember this is x, what is f at x? Well, x is 0 is, I'll assume the scale is 1. So 0 is right here. So 1, 2, 3, f at x is right here. So it's just this point right here, which was 0, 3. So f at 0 is 3. F at 2 can do the same thing. So that means x is 2. That would be this point right here, where we're right on the graph. So we have 2, and the f at x value is 0. So that means sort of the height of the graph is 0. So just by looking at the graph, we can pick out different values of the rule. So we could do this for 0, 2, right? 0 is here, 2 is here. We could have done it for 4. We could do it for 3. It might be hard to tell. You could even do it for like numbers in between, right? 2, 3.5 right here. You could figure out what that point is in my graph. So there's really any point here I could do that. So here's the second question. what is the domain of f? And this, if you remember, is sort of why I said the graph is better than listing it, because I said that there was sort of an infinite number of points. So which values of x does this function cover? Well, the smallest one is here, right? This is the lowest value of x, which is right at -1. And the highest one is up here, which is the value 4. So -1 to -4, but it covers all values between -1 and 4. Right? If you can see, anything bigger than -1, right? So 0, that's obvious on the graph, but anything in between -1 and 0 even, right? So like -0.5, that's on the graph, and -0.4 and 3 and 2, but any number in between -1 and 4. So the domain is the set of numbers between -1, set of all x between -1 and 4, and it actually includes these numbers, so we'll say strictly, or not strictly, including -1 and 4. Another way you'll see that written is in interval notation. You say x is an element of the interval from -1 to 4. So these square brackets indicate we include -1 and 4, and it just means any number between -1 and 4. So this is the domain. So that was a horizontal line right there. How about the range? What is So go back to the graph, and we just need to see what's the smallest value. So the smallest value of the range. So remember, the range is the vertical values, the f at x. So which values does f at x take on? So the smallest sort of up and down vertical value is this one here. So that's 0. The biggest one is up here at 3. And we cover all values between here, right? The function covers everything between 3 and 0. So the range, usually the letter we'll use for range is y. So y takes on the values from 0 all the way up to 3. Or you could use that sort of interval notation and say it goes from 0 to 3. So here you can see the advantage. Actually, when I write the domain, I should probably actually add that x is a real number. So it's any real number between -1 and 4. And I'll do the same thing for here. So y is any real number between 0 and 3. So you can see the advantage here, right? There was an infinite number of numbers between -1 and 4, but I didn't have to list them all because I had done the graph. So I wouldn't have been able to do that by just doing a mapping diagram or a table of values or one of the other methods. So sometimes a graph is one of your better, or is your only option really, or is a better alternative than the other ways. There's actually another way which we'll talk about in the next video.